Lately, I have been investigating the state of DevOps job market in general, and I'm talking about across the board in developed economy. I'm not sure about developing economy, but I can see a pattern here. A lot of people made me question, is it dead? But answer is actually mixed. So part of the reason that you see a lower number of job opening is the continuation of the tech slowdown. We started around 2023 and it's still going on. You can see so many layoffs are still being announced and less number of developer tech staff mean overall less demand for any DevOps. Second, the most crucial part is AI is changing DevOps. That is a fact, it is undeniable. So before I actually go into how AI is changing the DevOps. Let's go back and see what the DevOps was all about when it was on a heydays, right? So, rise of DevOps, you can think of a around last decade, pretty much coincided with the rise of AWS, agile-based software development, and SaaS software boom. And why suddenly we need DevOps people during that time? Remember one thing: once you move from an agile-based workflow to a let's explore why adoption of Agile led to a massive demand in DevOps engineers. Back in days of 2000 when I started my career, the release cycle used to be 1 year or maybe twice a year or maybe three times most frequent. And during those release time, you have to do all these very structured approach like design, development, and then QA testing, and then you do the deployment. Deployment used to take sometimes weeks to do that, and we will be staying up at night at the office to get the job done because once you're doing a large deployment, so often what happens is you're doing a breaking changes and it can go wrong either way. So you need to make sure it is tested properly. With Agile, the philosophy changed dramatically. What it said that instead of doing the final design, let's do a little bit of work and release it. Little bit of work, release it. What it led to the demand for rapid and quick feature release as opposed to a giant feature release. And now, when I'm talking about this thing, you see everything changes dramatically. Because now, earlier in the traditional system, when you had sysadmin, build engineer, DevOps engineer, not DevOps like a build engineer, release engineer, they would have specific tasks to manage that large branch of code. And that was needed. That was very specialized and I would say often siloed approach. With agile based workflow, what you needed is a collaborative pod which is actually working on a common goal and shipping code very frequently. And in order to do that, you cannot have a basically you don't have flexibility to having so many people and you have to do automation. Now once you start doing automation, then you see a more generalistic person comes into the picture who is not expert at scripting, not expert at system admin, not expert at build, but he or she is a jack of all trades. So they can do a decent enough job to automate the whole thing and get the job to finish line. So that was a evolution and the massive boom of DevOps. And as DevOps progressed through the years, so evolution happened from generalistic to specialized tasks. Why? Led to these massive explosion of software architecture, microservices, cloud, multi-cloud, API, big data, containerization, Docker, Kubernetes, and that led to a very complicated set of software architecture. And then it became almost impossible that one person will know everything because now so many specialization building is extremely hard. So now we are talking about specialized tasks inside the realm of DevOps which started growing up. And you can see from this particular diagram that we are talking about the evolution of DevOps. The evolution of DevOps became to a multiple task based work. So cloud admin, CI/CD people, infrastructure as code, production support, scripting. So you can see that DevOps actually got specialized into small pieces, and now we are doing the reverse of it. DevOps was a single generalistic person or multiple. Now we are talking about specialized person who are focusing on each and every component. And as we go through it, something else happened, often known as ClickOps or WebOps. What is that? Because now you're talking about very complex deployment. It means there will be tool available for you to make your job easy. Example, template based workflow, GitHub Action, Jenkins file. The cloud console become really user friendly. Example, if you want to deploy a VPC right now in AWS, literally it is a single page deployment. Earlier, in back in the early days, it used to be multi-page design. You have to select multiple options. Now everything is pre-configured. What had led that a new generation of engineers came along, they might have never seen the complexity of the on-prem or earlier generation software or infrastructure. So they have been accustomed to these simple and template-based workflow. And the good thing about cloud is it just works. As long as you follow the instruction of AWS, it just works. So the need for someone to know the deep design detail of software architecture, infrastructure architecture, network architecture become less and less relevant. And that led to another evolution, which is container evolution. It means if something goes wrong, simply restart the container. Just kill the container, everything will come back, and we are all good and happy. And that led the tool become really powerful, and that is how we call it a WebOps, ClickOps, or I would say ops, who are actually following the instruction, or rather than actually doing any engineering investigation. And that design pattern work really well. You can see how a task-based work, task-based specialist actually became a tool-based specialist. When I'm talking about cloud console, I'm talking about people often specialize on Amazon console. They are just pro on that, and they may not know a lot about Azure and GCP. Similar applies to GitHub people. If they are very specialized on GitLab and they have in that ecosystem, they may not know other CI tool. As far as infrastructure as code goes, pretty much Terraform is the market leader. There are some other players like Palomi and other, but pretty much people become Terraform developers. L1 support, as I mentioned, a lot of time L1 support, even on a Kubernetes system. I've seen people with certified Kubernetes administration experience, they hardly understand why they are doing that task they are doing. They are simply restarting the pods, deploying the Helm chart, and they have no understanding what application they are deploying, how the API workflow is working, which port is open, which port is closed. Often the case, what happens if you deploy the Helm chart, if it works, it doesn't work, then you just keep retrying. And you can see scripting has become pretty much, people are running predefined Ansible playbooks. And of course, everything can be generated through AI, so that makes it even less relevant of a skill. While all these things were happening, one thing was also happening at the same time. All these individuals, they lack certain skills, or I would say concepts, cross functional knowledge about a cross software stack, lack of understanding of software architecture, operating system fundamentals, network fundamentals were pretty much gone. If you ask someone about difference between L3 and L4, very few people can answer. Data platform and full stack application platform. Because remember, when you are a DevOps or any engineer, people are not, at least nowadays, hiring to build you a CI/CD pipeline. They are hiring you to actually take an application and make it a really good efficient deployment. So it means you need to understand other data platform, because most cases enterprise, either they are running a complex data platform or they're running a full stack application. So here is another thing. And some, as long AI came along, and we all know AI is really good at currently instruction based system. You give a prompt, it gives you the code, it executes it. Fixed and clear steps. Linear problem is a unidimensional problem. You're doing it. I know a lot of reasoning models are coming there, but they are not good there yet in a giving you a deterministic solution. And anything which is serial execution, all these tool based skills are a perfect candidate to be replaced by AI. Remember, take an example. If you're talking about a cloud console operation, all we know that AI is very good at imitating. So, example, if I show it a workflow, whether it could be a video model on my screen, it can actually automate it, emulate it. I'm talking about, say, CI/CD pipeline creation with a template and Copilot. It has become so simple that pretty much you don't need a additional person to do that. Any developer, they can do themselves. In my team, I never hire any more DevOps just to build a pipeline. That role is gone pretty much almost 3 years now. Talking about Terraform and all other tools, you can see all these AI tools are coming along. So you can see the picture how it is setting up. So the evolution, how the DevOps from a generalistic to a specialization to a tool-based skill, and eventually a tool which can be replaced by AI, it is playing out. And that is leading to a lack of demand for specialized skill on a particular skill set, especially it applies to DevOps. And what we see right now is nothing new. This has been played out in past. If you go back in history, any of the previous tech cycle, people have faced this. I just use ChatGPT to generate this table. Maybe correct, maybe not, but most few of the tech cycle I have seen by myself. Remember one thing: DevOps was a cycle in that a lot of legacy job got replaced with this DevOps and SRE role. Some of the top DevOps skills which were very high demand, I would say pre 2018, they are at a risk to be replaced by AI. Pipeline creation, which has already been pretty much replaced by all AI tools. Biggest example is your GitHub Copilot. Infrastructure as code, all you can use any of those tools. They can generate pretty nice Terraform template. Ansible playbook, PromQL, and any WebOps and ClickOps skill. But here is opportunity because remember, AI is just like any other tech cycle. It goes through every 3 to 5 years of cycle. Right now, the opportunity is that if your skill is multi-dimensional and cross-functional, where AI cannot reason enough and it cannot actually create a chain of thought, or a group of AI agent cannot achieve their goal, then there is a human is valued, and the value will be much higher. That includes administration skill, troubleshooting skill, complex infrastructure understanding, understanding of the nitty gritty of the software architecture. Last but not the least is the troubleshooting. AI cannot troubleshoot. That is the fact. And you can see a lot of demos of how AI is doing troubleshooting, but those are in a very closed environment. In real world scenario, they do not work. So what are the choice? Leverage AI or replace by AI? Of course, as a human, we need to progress and we will leverage AI to get better. One thing I want to clear here, just learning how to use ChatGPT is not learning AI. It will be like saying 20 years back, hey, I'm learning Google. No, it's just a tool. You're asking it, it's giving you query. Sometimes it is giving you a right answer, sometimes not. So what is the solution? Solution, I will give you analogy of a plumber. Imagine a plumber who can only use one tool, wrench, that's it. If that person comes to your home with only one tool, he or she may not be able to fix the problem that you're looking for because he or she has only one tool. That's why you see plumbers, they come with variety of tools. And that is the versatility of plumber. And that's why plumber will never be replaced by any AI. Same thing we have to apply in our skill set, which is platform engineering for AI. Platform engineering for AI is focused on taking all the concepts that we have accumulated or may have forgotten as a part of DevOps, automation, and the ClickOps evolution. We might have to relearn it or maybe build up the stack. That includes getting really good with using Copilot to generate your code, your pipeline. Linux, you need to know Linux. You need to know troubleshooting the Linux, little bit about it, at least some level of administration. Remember, Linux is running pretty much all infrastructure right now, AI or non AI. Understanding of the GPU technology, specifically the InfiniBand, the Fabric network, and how you can tweak the power of GPU to get maximum throughput for inference or training, because a lot of opportunities are over there. Neo cloud. What is Neo cloud? Neo cloud are the new generation cloud who are building massive amount of data center in order to service the demand for AI. And often their user interface or their topology is not as user friendly as Amazon's or Azure's of the world. In that case, you have to go to the weeds of it and understand it. And that is a really valuable skill. Programming language. I have put Python here, you can pick Go. Remember one thing, even if you use vibe coding to write any code, eventually you have to support that code in the long term. And AI is not very good at that. AI is just, it can generate a code, a template, but you have to modify the code, optimize the code, and make sure it is performant and running on production to the best quality. For that purpose, you need to know the fundamentals of programming. You cannot shy away from that. Then, usual suspect, Docker Kubernetes, any application running AI or non AI, they are all containerized, cloud native, and you need to be comfortable with these tools. Hugging Face ecosystem is a new kind of repository just for models, and you need to get used to it, how to use this model, and also a little bit about LLM ops, like basic hypertuning, how to run inference. Again, here we are not talking about becoming a machine learning engineer, rather, we are talking about helping ML engineer to run their model as efficient as possible. And observability and security goes hand in hand because till today, most of the security threat what is happening, you will see AI will actually create the volume of the threat even higher, and you need to know before in hand. Now let's go to the what AI opportunities are here. Most of the whatever opportunity what I see is pretty much on the existing job, where you're using these copilot based tools to leverage and make your life better. LLM training job, these are pretty much, I would say, machine learning jobs, and a lot of opportunities coming around AI new cloud space because they need a massive amount of engineers who can set up, build infrastructure, and understand in and out of a complex computer infrastructure. AI app development, which is everywhere. Every .ai company is a AI app company. So having said that, so before we actually start exploring, okay, how to tackle this field, how to get into this new field, we need to understand what is a AI stack. The example I'm giving here is a very usual AI stack, which is very popular. You have a some kind of cloud, new cloud or hyperscaler. They are running a some kind of GPU acceleration platform. In this case, I have chosen NVIDIA because this is the de facto in most cases. Other platforms such as AMD and Intel, they also have their own platform. The platform orchestration, Linux and Kubernetes. Models, I have given example of two of the most popular open source model, Llama and DeepSeek. And on top, you have API, all these agents. So this is a model going on. And where do you fit as your skill set lies is you can pick the stack. Remember one thing, no single person will be able to do all of the stack. You have to pick and choose a stack and specialize on that, and that is how you build up your career. So when we are talking about AI tech stack, you can divide into these pieces. One is your hardware. When you're talking about NVIDIA based or AMD based system, NVLink, Rocky, these are fabric network, which mean how a GPU to GPU communication happens, bypassing the whole CPU interrupt cycle. That is the main breakthrough in all these GPU to GPU training. Platform, you're talking about Linux, CUDA, Kubernetes, LLMs. You can use either open source model or closed source, but for this discussion, I will more emphasize on open source because that is where you have a control. Closed source model, you either have to work for Google or OpenAI, and that is a different story altogether. Apps. Once you have the LLM working, you can actually use those APIs to create any app, and most of the .ai company, including the vibe coding companies, using these APIs. And the bulk of the job, according to me, will be created on these last three sections, which is your apps, app dev platforms, and the cloud. Is that you can actually achieve this platform engineering career is this learning path. Of course, people can choose different learning path, but this is one of it. Is you start with any of the programming language, and you can use a some copilot or any AI tool to write the code, but make sure you are able to understand the code. and be very comfortable with Git workflow. Build a full stack project. And next one is getting really hands-on experience on Linux. And when I'm talking about Linux, you should be able to do basic troubleshooting in command line interface and able to run a lot of networking command and able to understand different layer of networking stack, specifically L3 and L4 and L2. Now, once we have a solid understanding of the platform, now we go to Docker and Kubernetes, which is essentially a container orchestration platform. And how we relate all these things. Example, the code I wrote on Python using AI, talking to AI, that particular application I will containerize. And during the process of containerization, I will learn a lot of painful lesson about Docker. And once containerization is done, I will write a Helm chart from scratch for that application. Again, I will use AI here, but I will know what I'm asking AI and I'm validating everything. Once I have got comfortable, I will deploy the project. And same principle will be applicable to while I'm learning LLM ops. LLM ops, I will pick up with any cloud or I have a laptop with NVIDIA. I will play over there. Otherwise, we'll partner with any of the new cloud. If you are joining our program, we have partnered with many new cloud providers and you will have access to that. And last but not the least, once your whole application is running, you have to make sure it is site reliability engineering approved, mean it has observability, security, and alert monitoring. And if you do the whole stack for multiple type of application, full stack application, data platforms, complex data solution, large language model, RAG, after doing that, you will have a decent comfort and confidence knowing that whatever you know, it is AI proof and AI. Once you have done this project multiple times for different system, for example, for full stack application, for data platform, for RAG, for LLM, for inference, then you will know even though
Your portfolio project on GitHub, doing a lot of commits in a public repository will definitely boost your profile. And based on this, we have created a specialized AI platform engineering training platform altogether, which includes online learning, daily classes, Q&A, and project-based learning. The detail will be shared in the link below. All these things always starts with a basic technology foundation where we will decode the AI tech stack, fundamentals of software engineering, software development, and we'll start with Python. Once it is done, we always finish a module with a quiz and a project and something that you can showcase in your GitHub open source profile. Then, of course, Linux and network administration. Once you get comfort with the base stack, then you start focusing on higher level items such as cloud. And this time, when you're learning cloud, you're learning cloud agnostic because you never know the job that you're looking for, applying for, which cloud do they live on. Because 5 years ago, it was all Amazon. But now, other cloud providers, GCP, Azure, have really picked up. And then we start on cloud automation, Docker, and Kubernetes. And while we are doing all these things, we are not just sitting idle. We are also learning AI tools and also preparing interview for every step. Example, when you finish the Python module, we are also working on interview questions of Python. When we finished Linux administration, we are also preparing for Linux interview questions because remember, we don't have to wait for a job till the end of the program. As we learn, we apply the jobs and keep giving interview so that we getting better. And of course, you can see the later part of the course focuses more on a project-based learning. Because remember, nobody's going to hire a DevOps engineer just to build a pipeline anymore. Those days are gone. They're hiring a DevOps SRE or a platform engineer to orchestrate the life cycle of an application. It could be enterprise application running a data pipeline, or it could be a e-commerce application running a full stack application. So until unless you understand the nitty-gritties of running a platform, could be data platform or application platform, your likelihood of being successful in a job interview is very less. And as we continue with the data engineering, GPU acceleration, LLM ops, RAG ops, and then you'll be set for success.